Yes, sir. Oh, okay, that's fine. You get another one. There's always should be some spare graph paper in the back here, guys. If you ever need any more, I usually have on this bottom. There's usually some on that bottom tray there, and then if not, I'll get some more. I'll make some more today also. There you go. And if you need to, there's a hole punch somewhere right there on the desk here, or on my computer there. So help yourself if you want to. All right. So absolute value. Do you guys remember what absolute value meant? Yes, ma'am. Yeah. Absolute value is always how far away something is from zero. So what I want to show you guys is something how you do this in the calculator first. That's not a calculator. Okay, so we'll reset that here. Go to your y equals. Oh, I gotta clear out my stuff. And what I want to do is I'm going to graph an absolute value. I'm trying to remember which one. I think it's under alpha window. Alpha window brings up a bunch of shortcut keys. The very first option says ABS, and you'll notice in blue, I think yours has a little bit of blue also, what it's going to look like. Uprights mean absolute value. Okay, so go ahead and hit enter because it's already highlighted on one. And right now, let's just put X. Okay, and hit graph. Okay. It's a V, isn't it? Okay. It's a V. Now think about it. When you have absolute value, will your distance ever be negative? No. So go to your table real quick. Hit second table. Do any of your most of your tables should start at 0. Does anybody have a table that does not start at 0? Okay. What did yours start at? What one? Okay. If you want yours to start at 0, -2 isn't a bad thing to always start at. It's not a problem. But if you wanted, if your window is all sorts of whacked and messy or anything like that, if you need to adjust where the table starts at, and this is good to know in case this does happen, because I think in chemistry or physics or some science class, they mess around with tables a lot. How do you reset your table? You hit second window because it says table set, and it starts out with table setup. Right there, you can set what value you want your table to start at. Usually I start mine at 0. Okay. Does that make sense? So if you wanted to change yours from -2 to 0, go for it. Sometimes, most of you guys got all brand new calculators this year, so they still had the cellophane wrapped on it. In years past, when we passed calculators out, obviously the memory and some of the RAM's still stored in it, so somebody could have had it like really all sorts of messed up. That's why whenever I give you guys calculators, I always say, hey, let's clear the memory, reset defaults. It's a clean way of doing it. Okay? All right, back to the table. Now hit second table. Now, right now, if you have yours starting at 0, you'll see when you substitute in 1, get 1, 2, 2, so on and so on. But if you go up to your negatives, obviously, what's the absolute value of -5? 5, and so on and so on. So what it's doing is calculating everything for you. Okay? Go back to your y equals. Let's go down 1. We'll make another graph. Let's do 2. And then we'll do our the alpha window. And then we're going to make another absolute value graph. Hit enter. And let's just put in X. Okay. Now hit graph. What changed? It got steeper. When you say steeper, what's changing? Excellent. Slope. The slope changed, didn't it? Okay. the slope change became steeper. So if you start thinking about how the order of operations work, absolute value, you treat that like you would parentheses in terms of the order of operations. So if you substitute in 4 into there, what's the absolute value of 4? 4, what's 4 times 2? 8. So if you look at your table, I bet you when you're at 4, your answer is 8. Okay. Let's try another one. Go back to your y equals. Go down to the third one. Let's do 2 alpha window, enter x. Now go on the outside of it, hit the right arrow, and I want to do plus 3. Okay, plus 3. Now hit graph. What happened? It moved up 3, didn't it? Did the slope change? No. The value itself moved up 3. So if you start thinking about order of operations here, if I take my value of 0 for x, what's the absolute value of 0? 0. What's 2 times 0? 0. What's 0 plus 3? 3. So that means at 0, my y value is 3. Okay? So what you're doing here is it's going through the process of moving stuff around. Okay? Let's try one more. Go to our y equals. Move it down again. Let's go to the fourth one. Let's do a 2 again. Alpha, window, enter, x. Oops, I'm sorry. Stay inside there for a second. I want to do minus 2 inside of the absolute value. And then I'm also going to keep it at plus 3. Hit graph. Where did it go? It went to the side. What side did it go to? It went to the right. How many spots did it go to the right? 2. So it moved horizontally 2. It's moved vertically 3. Which way is horizontal on a graph? Left to right, your x values. What comes first in the alphabet, x or a y? What comes first in the alphabet, horizontal or vertical? Horizontal. So vertical then happens to relate to the y values. So what's going to happen here is that we're going to be able to take these styles of graphs, and this is going to be our first introduction to this, of having what's called a parent function and a shifted function. Okay? A parent function is absolute value of x, our blue line. The shifted function is when we put a multiplier in front of it. We changed its slope. Another shifted function is when we moved it vertically. We changed the y value. And then lastly, we shifted to the right by moving it horizontally by its x value. Now, can you have an absolute value graph that goes downward? Oh, take a guess. Now, where do you put the negative? Perfect. Watch this. Absolute, go back to here, go down again. Let's do negative 2, alpha window x, alpha window 1, sorry. And then just hit X and we'll hit graph and watch what that one does. What it's doing is using the order of operations. Order of operations says take the absolute value of x first and then multiply it by negative 2. That's how we can invert it by flipping the slope. There's a multiplier out in front. Staying with me here? So what happens is you get this idea that you have this would be a parent function. This is the parent function of what in every single absolute value graph has to have something like this. Has to have the absolute value. To that, we add the shifted function. We get a shifted function of an absolute value, and it looks like this. A, H, and K. These values of A, H, and K are going to be with us the entire school year. And they're always going to mean the same thing. A is a multiplier, H and K is a shift, horizontally and vertically. That's exactly why I do that. And I said this the other, I've been saying it a while, there's a reason why I do that. This is the reason. Okay. And it's dumb, but you're going to remember horizontal and vertical for H and K. Where in an absolute value graph, HK is where you start. And A is your slope. H and K is where you start, A is your slope. And this just takes a little getting used to of how it's written. If we go back real quick, and I'm just going to pull the y equals table that I had here. Just bring this in. Move this up just a bit here. What's my value of A on our fourth graph? 2. So as we get going on these things, what I'd like you guys to do first of all, before we graph them, is label. A is 2. What's H? It's positive 2. Remember, it's just minus H. So it's kind of those things where you get used to the negative part there. So if it's minus 2, it means it's 2. If it's plus 2, it means it's negative. So H is 2, and the K value is always whatever that number is, whether it's plus or minus. In this case, K is 3. Which means if I had a graph, I would start this at 2, 3, and I would walk my slope of up 2 over 1, up 2 over 1, or up 2, left 1, up 2, left 1. And there's my graph. That's what it does. That's exactly what it does. The slopes on absolute values will just go both directions. That's how you get both sides of the graph to show. Right. A, H, and K. They're going to be your best friend. Well, they might be. Okay. Let's try another one. One little trick that you'll see, the smaller your A value is, the bigger the V. Yeah. The bigger the V, the larger your A value is, the narrower the V is. Because in terms of slope, think of steepness. A slope of 5 is steeper than a slope of 1/5. So I was watching the circus news this morning, Channel 9, is what's on it, those guys are funny. And they showed a clip of a panda falling out of a tree, and I couldn't stop laughing. It was funny, they were just sitting in the tree, and the tree branch broke, and it fell. And like, ah! He was fine. I just thought it was funny. Anecdotal nonsense from Murphy. Then I would have felt bad for the panda, but the panda didn't break his leg, so then I can laugh at him. You've never laughed at somebody falling? If I just walked and tripped over my own feet and fell, you would laugh, right? Exactly. What's the difference of looking at a panda? I'm peaceful. Shut up. What's your A value here? 1/2. Where are you going to start this graph at? 2, -3. Very good. So I go find 2, -3, put a dot, and now I just walk my slope. Up 1 over 2. Up 1 over 2. Up 1, left 2. Make your V. We're all good. Absolute value graphs are really the nicest graphs to introduce you guys to AH and K. Yes, sir. What happens here is when you have the format where it's x minus h, since our graph here was x minus 2, that means h is 2. If it was x plus 2, that meant that it had to been a minus and -2 to generate the h. Okay? It's one of those subtleties that you'll get used to with the h's and k's. H's are always like this, k's usually aren't because they're outside of the parentheses. Good Friday stuff, isn't it? Kind of. -2/3 times the absolute value of x plus 6, all minus 4. Yeah, sometimes I forget to press stop while you do it. What's your value of A? What's your ordered pair to start at? Excelente. Okay, bueno. -6. 4. What was it? Down 2, right 3. Down 2, right 3. Down 2, right 3. That's close enough. It's close enough. You know, we're trying to learn just a little bit about parent functions and what things will look like. AH and K's never go away. All right. Could you write the equation if I give you a graph? Could you write the equation given the graph? I need it. Really can't blow that up without destroying the entire graph, so you'll have to squint and hopefully you can see it just fine. You should go next door and harass them. They're taking a quiz. Oh, we should. We will. There's a time and a place. Nah, they take the quiz. We still got a geometry quiz. Yeah, right. They're already frightened. I walked in, they're not suppressed, right? So it's good. Raylan's all right. Just fine. Very good. So, what's the H and K value here, guys? Where's your center here, if you will? Our center's at 3, 1. Whoa, if H is -3, then it would have been. What's your slope? Negative 1, so we went down 1 little 2 little 3, 1 little 2, yep, down 1. Put it all together. Y equals A, absolute value x minus h plus k. So it's negative 1, absolute value x minus 3 plus 1. Do you have to put the 1 there, or you can just put negative absolute value? Either one of them is fine. It's okay. If you want to save ink, go for it. Let's see. How much graph paper you guys got left? Do you guys have, you should have, do you have 3 open spots on a piece of graph paper so I don't have to take more copies of it right now? Okay. So if you screw up once, you'll be fine. So I got 3 graphs, and then I got 6 of them to write out. I'm sure you can knock this out rapidly. Or you can start now and not have to worry about any of it. No, you're not. Are you that cold? Did you see that they sell sleeping bags now that are just giant mummy bags where you, like, it's just like a snuggie thing? I saw it at all places. I saw it in Aldi. I know. Aldi. Aldi is weird because they have all these randomly weird things, but man, I love their food. What's that? I want a tie for $1. It was great. Let me republish that. I just did it. I'd have